Hello students, welcome to the YouTube channel Physics Simplified. Here, we will understand numerous concepts of physics from a numerical perspective. So, without any further delay, let's jump into the discussion. Topic of discussion for today's video: magnetic field due to a moving point charge. In this problem, an alpha particle and an electron are moving in two opposite directions from the same point with the same speed, given as 2 into 10 to the power 5 meters per second. This is depicted in the given figure. We need to find the magnitude and direction of the total magnetic field these charges produce at point A, which is 8.65 nanometers from each charge. Let us now identify the concept we need to solve this problem. Here both the alpha particle and the electron are moving with constant velocities. So, both the charges produce their own magnetic fields. Hence, the net magnetic field at the given point is the vector sum of these two fields. Now, we will set up the required equation to solve the problem. Both the magnetic fields produced by the two charges point out of the paper. This can be determined by the right-hand rule for the magnetic field due to a positive charge moving at constant velocity. See the diagram. The direction of motion of the positive charge is shown. If we now point the thumb of our right hand in the direction of the velocity of the charge, the curl of our fingers around the charge give the direction of the magnetic field lines. So, we can state the rule as follows. If we point the thumb of our right hand in the direction of the velocity of the charge, our fingers curl around the charge in the direction of the magnetic field lines. Remember, if the moving charge is negative, the field lines are in the opposite direction. Now it is clear to us why the magnetic fields produced by the two charges point out of the paper. So, the magnitude of the total magnetic field is equal to the algebraic sum of the magnitudes of the two fields. Therefore, mathematically, B suffix total, which denotes the total magnetic field, is equal to B suffix alpha plus B suffix electron. The two terms in the right-hand side of the equation represents the magnitude of the individual fields created by the alpha particle and the electron respectively. Let us now build up the final equation using the said concept. From the given problem, we get the following data for the alpha particle. Charge of the alpha particle, denoted by Q1, is equal to plus 2e. Here, E is the magnitude of one electronic charge, which is equal to 1.602 into 10 to the power minus 19 coulomb. Velocity, V, is equal to 2 into 10 to the power 5 meters per second. Distance of the given point A from the alpha particle, R, is equal to 8.65 nanometer, that is, 8.65 into 10 to the power minus 9 meter. And the angle between the line from the alpha particle to the field point A and the velocity of the charge, denoted by θ1, is equal to 150 degrees. Similarly, the given data for the electron are as follows. Magnitude of the charge of the electron, Q2, is equal to E. Velocity is the same, that is, 2 into 10 to the power 5 meters per second. Distance of the given point A from the electron is also the same, that is 8.65 nanometer, which is equal to 8.65 into 10 to the power minus 9 meter. But the angle denoted by θ2 is equal to 180 degrees minus 150 degrees, that is 30 degrees. The reference equation to determine the magnitude of the magnetic field produced by a uniformly moving point charge is B is equal to mu 0 by 4 pi times qv sin theta divided by r squared. From this equation, we get the expressions of the magnetic fields produced by the alpha particle and the electron respectively. Remember, mu 0 by 4 pi is always equal to 10 to the power minus 7 Tesla meter per ampere. So, the magnitude of the magnetic field at the given point A is given by B suffix A, and this is equal to algebraic sum of B suffix alpha and B suffix electron. By substituting the corresponding expression for the alpha particle and electron, we get this equation. This can be written as B suffix A is equal to mu 0 by 4 pi times V by R squared times within first bracket 2 e sine theta 1 plus e sine theta 2. Factoring out an e and putting in the numbers gives the following equation. After simplifying the calculation, we get B suffix A is equal to 6.423 into 10 to the power minus 5 Tesla. As we have already determined the direction of the net magnetic field at point A points out of the paper, hence the final result is as follows. The magnitude of the total magnetic field at point A produced by the oppositely moving alpha particle and the electron is equal to 6.423 into 10 to the power minus 5 Tesla, and it is directed out of the paper. It is denoted by the symbol encircled dot.